So let's go back a bit before Anderson's discovery of the positron or the antiparticle of the electron. So back in 1928, um, a genius physicist in the name of Paul Dirac derived a relativistic version of the Schrodinger equation. So to briefly explain Schrodinger equation, it defines particles in terms of waves, and it is used to explain the behavior of certain particles in terms of the wave function. So Paul Dirac created an equation which is a relativistic version of the Schrodinger equation. So he used the Dirac equation to solve the wave function of a free electron. And upon his solution, he predicted that upon his solution, it was shown that there should be negative energy states present in the allowed energy states for the free electron. So, in reference to the uh, the original Schrodinger equation, when we solve it for a free particle, negative energy states do not appear in the allowed energy states for a free electron. But in relativistic Schrodinger equation, Dirac shown that these negative energy states are part of the solution. So he thought of what particles could have existed in these negative energy states. So initially he thought they might be protons, and in later experiments, which what we learned earlier, Anderson, that his discovery of the positron explained the negative energy states, which was originally predicted by the Dirac equation. So what do we mean by negative energy states? So here in the leftmost figure, we have a figure that gives the allowed energies for an electron. So in this line, we have an energy corresponding to the rest mass energy of an electron. So me times c square, and then so on, following the allowed energies. So in Dirac solution, he predicted that negative energy states are allowed for the free electron, particularly negative of the negative energy of its rest mass energies. So this, according to Dirac, these states should be allowed. So if we have an electron, say, in this state, in the negative energy state, and it has an energy of this amount, its rest mass energy minus mec squared, and then you apply a photon, you give it energy of 2 mec squared. So this electron will jump into from this state to this state. So this is 1 mec squared, this is another 1 mec squared. Hence, you will produce the electron. So this electron is that occupied this state of the negative energy level is the positron. And in order that a positron transition from be converted into an electron, you should give it an energy of 2 MEC squared. And this process is called production. So this is an electron positron production. On the other hand, if you have an electron sitting here with an energy of its rest mass energy MEC squared, or in other words, a free electron, if it gives off energy with the same amount as 2 m sub e c squared, it will be converted into a no, it will not be converted. Uh, it will go back to its original state, and the two particles will be annihilated. So this process is called annihilation, and it releases an energy in this amount.